Good day, everyone. I hope you have a good day today because we are going to discuss a very interesting topic. But before we start, let me ask you first a question. Are you curious how the string of the guitar works? When you strum a guitar string, you created a disturbance due to the force applied to the string. Due to the string's elasticity, the disturbance that you created will cause the string to vibrate in a particular way. The vibration is due to your energy applied which pass from the molecules of the string and eventually it will transfer to the air molecules to compress in a periodic pattern. How interesting though that these strings of the guitar follows the physics rules. Our topic for today will elaborate further these rules and that is the waves. Specifically, we will be tackling about the mechanical waves. But let us first discuss the medium of the wave. The medium of the waves is the substance which such waves travels. It serves as the tool for the waves to travel. Hence, it is also the air molecules for the sound. The energy of a mechanical wave can only travel through this medium. We will be taking note that the waves transmit energy and not particles, just like the example before which is the string. We observe that energy are being transferred to the molecule rather than the particles. These energy are being transmitted in the waves by particles colliding to each other. The particles vibrate from their equilibrium position and colliding with nearby particles to also vibrate. Another example is when we slap the board. We hear the sounds after we done it. Likewise, there are waves that is short, non-periodic, and wave formed by a single put of energy. One of the best examples is the behavior of the flash of the camera. On the other hand, there are waves that has repeated input of energy and steady. These are called continuous wave. For example, we observe the ripple in the water. Let us come now to the mechanical waves. Mechanical waves are type of waves that cannot travel without a medium. The medium can be solid, liquid, or even gas. This is because this type of wave cannot propagate in an empty space. That's why it needs medium to travel. Mechanical waves starts when the matter is being disturbed. Some of the best examples of mechanical waves are water waves and sound waves. Mechanical waves may come in different shapes and forms. The classifications of waves varies according to the orientation of the wave oscillations or how the particles moves relative to the direction of the waves. There are three categories including transverse, longitudinal, and surface or circular waves. Let us discuss these categories one by one. When we talk about the transverse waves, the particles are moving perpendicular 90 degrees to the direction of the wave, and the particles of the medium vibrates up and down. In the transverse waves, the bumpy parts here are called as crest, which is the highest point of the wave. On the other hand, the lowest point will be called as through, and the segment from the crest to the nearby through is a pulse. Another category of the mechanical wave is longitudinal wave. In this wave, the particles of the medium vibrates back and forth, parallel to the motion of the wave, which is the opposite of the transverse waves. When the wave moves towards right, the particles also moves towards right. One example is the slinky, which moves back and forth on one end while the other end is held fixed. In a longitudinal wave, compression and rarefactions are being created, wherein the high pressure is the compression and the rarefaction is the lower one. Hence, a pair of adjacent rarefaction and compression can pertain to a pulse. On the other hand, in the surface or circular waves, the particles are vibrating both up and down and back and forth. So they end up moving in a circle like an ocean wave. Hence, it is a combination of a transverse and longitudinal wave. For now, let us come on how mechanical waves are being measured. There are different quantities that can be used to describe a wave. This can be through wavelength, period, frequency, amplitude, and speed. First is the wavelength. It is the distance of a complete wave. It can be either crest to crest or from through to through of a transverse wave. And also, it can be from one complete rarefaction and one complete compression for a longitudinal wave. The second one is the amplitude. It is defined as the maximum displacement of the particle of the medium from its state of equilibrium. As we observe, it is from the equilibrium up to the crest or through. Amplitude can be measured through meter, which is its unit. Next is the frequency with the symbol F. It is described as the number of cycles of a wave passing a point per unit time. It is said to be the reciprocal of period. It is represented by the equation F is equal to 1 over t. On the other hand, period is the time required for the complete one-wave cycle. It is expressed in seconds and represented by the capital T. It is also represented mathematically by T is equal to 1 over F, wherein F is the cycle per second or the hertz. Lastly is the wave speed. It is the rate of a movement of the disturbance. The wave speed can be affected by the properties of medium it travels, like mass and forces between particles. It can be represented as wave speed is equal to the square root of F over P, or wave speed is equal to the square root of F over M over L, wherein the linear mass density is the mass M divided by the L. To wrap it up, in our daily lives, there are things we didn't know how it works, just like the wave. There are things that waves will act on it, it's just like we didn't know it yet. I will end this discussion with a question for you to find answer for yourself. Can you give other examples of wave application that you observe every day? In your home, school, and anywhere. Try to figure out. That's it, everyone. This is my discussion in the mechanical wave. I am James D. Guarnes, BC3B. Thank you for listening and keep safe, everyone.